Hi students, in this lecture I am going to explain how to find out that H parameter values of a transistor of an amplifier, like a transistor amplifier parameters, input resistance, output resistance, and current gain and voltage gain parameters for particular configuration like common emitter and common base and common collector. What are the formulas, and then we'll see that how to convert one formula to one configuration to other configuration H parameter models. So here, first when we see this diagram, it is the H parameter model for C amplifier. So in this C amplifier means here emitter is connected to ground, and it is the base terminal, it is the collector terminal. So we know that a transistor H parameter model is this one, a input impedance Hi and a voltage source HR and VC and a current source HF and IB and admittance 1 by H0. When it is common emitter configuration, these parameters are subscripted with the extra term is H, like E, small e. So the parameter input impedance Hi, if it is common emitter configuration, this is called HIE, and HRE and output voltage VC, and HFE, it is a common emitter configuration and our input current is IB. So here it is IB, and 1 by HOE, and load resistor, we can connect load resistor at output side, and we can connect a source voltage at input side for an amplifier, and its internal resistance RS, small rs. We know that what is the H parameter model equation? Input voltage V1, output current I1. So when we replace this V1 and I2 for the common emitter configuration, that VB is equal to HIE IB, HRE VC. IC is equal to, this is also called, this is also represented with VB. So VB or VB is equal to HIE HIB plus HRE VC or VCE, and IC is equal to HFE IB HOE VCE. So these equations can be helpful to find out transistor amplifier parameters RI, R0, AI, AV. Let us see one by one. First, current gain. What is the current gain for common emitter configuration? So C amplifier, when we connect C amplifier and its equivalent hybrid model, then what is the current gain? We already calculated a transistor amplifier current gain formula. I is equal to A suffix I is equal to HF by 1 plus H0 into RL. Just extra one subscript added to this equation, HFE and H0 E. That is the only thing. So once we calculate that generalized transistor model, hybrid model equation for IAI, AI is equal to HF divided by 1 plus H0 RL. So for the transistor H parameter model in common emitter configuration, that extra term is added, HFE and H0E or HOE. This is called current gain. So in the examination they have given forward current gain in common emitter configuration, which is represented with the HFE. HOE, output admittance in common emitter configuration, HOE. So that we will calculate a current gain by substituting HFE divided by 1 plus H0 HOE into small r. And input impedance. What is the formula for input impedance? The formula for input impedance is HIE plus HRE current gain into RL. This is what we derived in previous slide, in previous lecture. So input impedance HI plus HR AI into RL. So here when we substitute AI equation, AI is equal to minus HFE divided by 1 plus HOE into RL, then the entire equation can be converted into first term as it is HIE minus. So when we replace this AI term with HFE, so minus HRE HFE divided by HOE plus 1 by RL. So this is the formula for input impedance in common emitter configuration. Suppose the equivalent diagram, if you see here, the equivalent diagram for the H parameter model in a C amplifier, the resistance impedance, like input impedance, we can see here in the H parameter, but not excluding of the source resistance. When it is source resistance included, the total input resistance can be represented with the RIS. This is represented with the RI. This is actual output impedance R0. When we considering load resistor, it is R0 LR R0 S. So output resistance by considering RL. So when we consider this, it is a RI. What is the entire resistance looking into port 1 and 1 dash? So this is the impedance we can measure from by looking into 1 and 1 dash is called RI. So what the entire input impedance from by seeing this port 1 is RI, then the equivalent diagram is RS voltage source, and then entire resistance can be represented with the RI. So RS and RI. So when we connected it like this, so this can be when we take it is a port 1 and 1 dash. So we can connect the entire thing is RI. So it is RI. So what will the total resistance is nothing but from between port and 1 and 1 dash. So they are in parallel by what is the total resistance. For example, Thevenin's resistance starts circling the voltage, and these two are in parallel. So that we can RS parallel RIS is nothing but input resistance we can measure here in parallel with the source resistance or base resistance, biasing resistance. So by including this source, including the voltage source internal resistance RIS RS, then what is the total amplifier resistance input resistance RIS is equal to RI in parallel with the biasing resistance or RI parallel with the RS. Then voltage gain. Next, voltage gain. That voltage gain AV is equal to AI RL divided by RI. So here the formula for AV is equal to current gain into load resistor divided by input impedance. We already calculated the AI here, and we have already calculated RI here. By substituting AI multiplied with the load resistor RL divided by RI, you will get the voltage gain. Okay. Otherwise, we can calculate AI RL, and by substituting RI formula, we can take this formula. So we can substitute HIE plus HRE AI into RL. Otherwise, we can substitute this one, so that we will get voltage gain. And what is output resistance? Output resistance R0 is equal to, we have a formula for generalized amplifier, RSHI divided by RSHO plus del H. So when it is a common emitter configuration, what is the output impedance for common emitter configuration? So how to measure the common emitter configuration or any configuration? The output resistance can be measured looking into port 2, R2 and R2 and 2 dash by considering source voltage 0 and load resistor infinite. So by considering these two conditions, upon setting up these two conditions, and measuring the output resistance between 2 and 2 dash 4 to 2, then R0 is equal to Rs plus HIE divided by Rs HOE into delta H. Delta H nothing but the determinant of H parameter values HI, HO minus HR, HF. In common emitter HIE, HOE, HRE, HFE. So once we find out the determinant, then substitute in the R0. R0 is equal to Rs plus HIE divided by Rs HOE plus delta H. So when we consider the output resistance of the complete stage, so for example it is a two-port network, so we can calculate the output resistance in this place only. So what is the total output resistance by considering this RL also? So by considering this RL, then whatever the entire port, whatever the entire output port output resistance looking into I2 and 2 dash can be considered single resistance, which is represented with R0, and then which is in parallel with the small RL, load resistor RL, so that this RL, which is nothing but measured in 2 and 2 dash looking into 2 and 2 dash, so can be entire thing is RL, capital RL, in parallel with the small RL, so that resultant output resistance ROS nothing but, so output resistance measured in by excluding load resistor is R0 by looking output port, and in parallel with the small RL, so that it is the resultant resistance is nothing but ROS, output resistance of the total amplifier stage. Then overall voltage gain is given by the, so we have already a small AV. So once we have connected this amplifier with the source resistance, then total voltage, overall voltage gain AV is equal to AV into Rs divided by Rs in plus RIS. So total voltage gain AV is equal to AV into Rs divided by Rs plus RIS. Here it is a voltage source Vs. Its internal resistance is Rs. Already we have calculated RIS. Here it is measured when input resistance. So total voltage gain AV is equal to AV into Rs divided by Rs plus RIS. Similarly, the overall current gain is given by the AIS is equal to the gain calculated by excluding the internal source resistance, and then Rs divided by Rs plus IRIS. Similar formulas, hybrid formula for common base configuration. Common base configuration, how to calculate this input resistance, output resistance, current gain and voltage gain for common base configuration, common base amplifier. So take the common base amplifier and its equivalent hybrid model. When we consider equivalent hybrid model, then what are the parameters, current gain, voltage gain and input resistance and output resistance? Very simple. When we replace that generalized current gain formula with a subscript small b in all h parameters. So what is the current gain for a generalized equation? AI is equal to minus hf by 1 plus h naught into RL, small RL. So when we substitute a small b subscript here, so hfb divided by 1 plus hob into RL. So then we will get a current gain AI. And then input resistance. So the input resistance formula HI plus HR AI into RL. So it is in common base amplifier, then substitute H in the place of HI, we can replace with HIB, and HR replaced with HRB, and current gain multiplied with the load resistor RL. And also in another way of expressing this input resistance, HI minus HR HF divided by HO plus 1 by RL. So when we replace this HI with HIB in the common base, HRB, HFB, HOB plus 1 by RL. So this is the internal input impedance RI. So when we in parallel, when we calculate the input hybrid modeled input resistance RI in parallel with the bias resistor, or sometimes we can call it as source voltage internal resistance RS. So RI parallel RS or RI parallel bias resistor RB. So that we can calculate the total stage input, total amplifier, common base amplifier stage input resistance RIS is equal to RI in parallel with the RB. Next, voltage gain. This voltage gain AV is equal to, here all same, here current gain into small RL divided by RI. AI already calculated, find in current gain, and then RI. Next preceding value is RI, we have already calculated. Then substitute AI, ratio of AI by RL into small RL, so that we will get voltage gain. So when we replace that current gain formula and input impedance formula in the equation, then we can get that current gain formula in common base configuration minus HFB divided by 1 plus HOB into RL. So that rearrange this equation, and then total final equation for the AV is HFB RL divided by HIB delta H into small RL. Or simply, if you don't want to find these formulas, then simply we can get a current gain input impedance multiplied with the RL. This is called voltage gain. So I'm just replacing that general H parameter, like all parameters calculated from generalized H parameter model of transistor amplifier. So output resistance now, output resistance generally RS plus HI divided by RS H0 plus delta H. So here we can replace this HI with the RHB, HIB, RS plus HIB, and RS plus HOB and delta H, where delta H nothing but, so if you take the common base configuration matrix form representation is, common base means base is common, emitter is input and collector is output. So when collector is output, collector current is output current, emitter is input, input is emitter current is input current. So the formula first one is input current and output input voltage and output current. What is input voltage here? Input voltage V1 nothing but VE or VEB, and output current IC is equal to, in matrix form, the H parameter model matrix form can be represented as IE VC. Two parameters in independent variables, VCE or VCB here. So here the H11, H12, H21, H22 parameters represented in common base configuration: input impedance, reverse voltage gain, forward current gain, output admittance. If it is common base, HIB, HRB, HFB, HOB. So now what is the delta H here? Delta H nothing but determinant of this matrix, H parameter model matrix, HIB, HOB minus HRB, HFB. Okay, so by substituting delta H in this output impedance, so that output impedance is equal to RS plus HIB in common base configuration input impedance divided by RS plus HOB plus RS HOB plus delta H. This is output resistance in common base configuration. Similarly, if you consider the entire stage by considering source voltage, source resistance and load resistor, then what is the total output resistance by consider load resistor? If you take a common base configuration, it is voltage source, it is internal resistance Rs, common source Vs, it is a transistor connected in common base. When we connect a transistor in common base, like a base is connected to ground and the input is emitter. In this case, we can consider the internal resistance Hi and a voltage source and the current source in parallel with the H0. So now this is connected with the RL. It is port 2 and 2 dash. Now by considering all the resistance by looking this port to 2 dash, which is called R0. Now when we replace the entire network, this entire network of output resistance with a simple R0 and this 2 and 2 dash terminals connected with RL, small RL. Now what is the total output resistance, ROS, output resistance of total stage? So this is nothing but in parallel with the RS, R0 and RL. So ROS is equal to R0 and in parallel with the RL. And overall voltage gain same. So main overall voltage gain capital AV is equal to AV voltage gain by considering by excluding RS. So AV into RS plus RS divided by RS plus RIS, and current gain. So current gain can also be calculated. So AIS is equal to AI current gain AI into RS divided by RS plus RIS. Here also similar thing, we can replace that H parameters second subscript with a small c in common collector configuration. So consider a common collector transistor amplifier. Find out the parameters input impedance, output impedance, current gain and voltage gain of common collector amplifier. Consider that in hybrid equivalent circuit and then find out the current gain. AI is equal to minus HF by 1 plus H0 into RL. Replace that HF with HFC in common collector and HY replace with HY. So I'm just simply connecting it by considering that small c terms in the H parameter values. So current gain AI is equal to HFC divided by 1 plus HY into RL, and input resistance Ri is equal to HIC input impedance HI. So HIC in common collector and HRC current gain into RL. This is also represented with HIC minus HRC HFC divided by HY plus small 1 by RL. By substituting the current gain formula minus HFC 1 by HOC HYE into RL, then you can get HIE minus HRC HFC divided by HYE plus RL. And consider total stage input resistance of the entire stage. So RIS is equal to RI in parallel with base resistor, biasing resistor, source resistor RS. So then we can calculate this one. Then voltage gain. So this voltage gain is nothing but current gain into small RL divided by RI. So we already calculated AI and calculated RI. The value substitute in the AI and RI. Then we can get the AI small RL divided by capital RI, nothing but input resistance of the CC configuration. Then We can also represent this one in terms of H parameters minus HFC RL divided by HIC plus del H RL, small RL. Suppose if you find already a RI, then it is better to go this equation. Suppose they have not asked to find out AI and RI, directly they find out voltage gain by considering the parameter H parameter, then directly we can substitute minus HFC RL divided by HIC plus delta H RL. Similarly, output resistance R0 is equal to RS plus HIC divided by RS HOC plus delta H. Delta H in common collector, we can represent it in common collector parameters in matrix form. In common collector means collector is connected to ground, base is input, emitter is output. So then input voltage nothing but VBC and output current nothing but IE is equal to H parameter values are H input impedance HIC, HRC, HFC, HOC into multiplied by independent variables V2 I1 V1 I2 I1 V2 I1 nothing but here IB, V2 nothing but here VC or VC. So that the determinant value is HIC, HOC minus HRC, HFC. Delta H we can calculate from this matrix, so that R0 output resistance is equal to RS plus HIC divided by RS into HOC plus delta H. These all hybrid formulas are helpful to find out the parameters input impedance, output impedance, voltage gain, current gain for any transistor amplifier, CE amplifier, CC amplifier and CB amplifier. So we are considering a transistor H parameter model and then extra biasing circuit, source voltage and source internal resistance and RL. If any amplifier considering all extra biasings, like if it is fixed bias, we can calculate that all parameters while calculating the input resistance. By considering the voltage divider bias, if it is voltage divider bias C amplifier, then what is the input resistance? For example, RI we have calculated here. Then what is the total stage resistance? Nothing but this RI is in parallel with the parallel combination of R1 and R2. So that R1 parallel R2 parallel that common emitter input resistance. This is parallel with if it is considered the source resistance, parallel with the source resistance. So while designing complete amplifier, so we consider all the parameters by drawing the equivalent H parameter model. Now this is the output resistance of this stage. So RS OS is equal to R0 parallel with RL, AB and current gain and AVS, total voltage, total stage voltage source and total overall current gain for the overall stage. Now by studying all the CE and CB and CC configurations, most of the times this specification sheet given for CE configurations. So the conversion formula is required in order to find out common base and common collector configurations when the given specifications are in terms of common emitter. So in order to convert them from one configuration to other configuration, amplifier H parameters, these are the conversion formulas for conversion formulas. First we will see that conversion formula for common base configuration when the manufacturing company given specification sheets for common emitter configuration. So the conversion formula for determining the values of H parameters of a transistor in common base configuration from common emitter H parameter values. The common emitter H parameter values are HIE, HRE, HFE, and HYE. These are the common emitter configuration parameters. So when we want to find out a base, common base, which is represented with the subscript, second subscript is small b. What is HIB? HIB in terms of common emitter configuration, HIB is equal to HIE divided by 1 plus HFE. 1 plus HFE. So all the terms, common terms, denominator multiplied by 1 plus HFE. And then what is the reverse voltage gain in common base configuration? HIE multiplied by HYE divided by 1 plus HFE. All are common emitter configuration parameters. So if you want to find out HRB, HIE, HYE divided by 1 plus HFE. And then HFB, how to calculate HFB? So in order to convert this HFB in terms of common emitter parameters, HFB is equal to 1 minus HFE and divided by 1 plus HFE. And HOB, output admittance in common base, HOE divided by 1 plus HFE. So here, if you consider the denominator term 1 plus HFB in all the terms, and then IB is equal to HIE 1 by n plus HFE, and HRB, it is numerator multiplied HIE and HYE, and HFE minus HFE, and HOB, which is equal to HOE. Then conversion formula for common collector configuration. The conversion formula for determining the H parameter values in common collector from common emitter H parameter values. So HIC, what is HIC? We can calculate from common emitter. HIC is equal to HIE, and HRC is equal to 1 minus HRE, which is approximately equal to 1 because HRE is far less than 1. So HRE is we can calculate in the graphical analysis. HRE is equal to 1 into 10 to the power of minus 4 value. So that it is far less than 1. So that HRC approximately equal to 1. And HFC, which is nothing but 1 minus HFE. In common collector configuration, what is the range of HFE? For example, what is the average value of HFE? For example, 50 to 200. So then what is the value of HFC here? Minus 1. Minus 1 minus HFE. For example, 1 minus HFE nothing but 49 to 199. So what is the range of 1 plus HFE? 1 plus HFE. So HFC is equal to common collector current gain. Gamma is equal to common base current gain plus 1. 51 and 201. So this value, for example, considering one value, if you consider 50, HFE is 50. So the value of HFC, nothing but gamma, which is nothing but beta. So gamma beta relation, gamma is always 1 plus beta. So here HFC is nothing but minus 51. So the minus indicates it is in common collector configuration. HOC, which is approximately equal to HOE. So these are the conversion formulas when they have given right side for H parameters. So when we want to find out a common collector configuration parameters by using these formulas, so that we can convert from one configuration to other configuration. Most of the times they have given common emitter configuration, then we can convert that common base configuration parameters. So once convert this one, we can substitute these parameters in calculating input resistance, output resistance, and current gain and voltage gain. These are the typical H parameter values for transistor. Typical H parameter value. So here first column input impedance, reverse voltage gain, forward current gain, and output admittance. In common emitter configuration, input impedance are approximately equal to some 1100 ohms, and then HR is equal to 2.5 10 to the power of minus 4. It is far less than 1. and in CC configuration HR is equal to 1 and CB 3 into 10 power minus 4. HF is in CE 50, HCC minus 50, and but here CB it is 0. It is a 0.95 to 0.99. So here H naught 25 microampere per volt, 25 microampere per volt in C and CC, but in CB this admittance H naught is equal to 0.49 microampere per volts. So this is about conversion of and that formulas, how to calculate the amplifier parameters, analysis parameters are input impedance, output impedance, current gain, and voltage gain in all C, CB, CC configurations and conversion formulas from CE to CB, CE to CC. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.